Hi, 8th graders. Welcome to the Science Lab. We're working on Lab 13, water distillation today. And the first thing that we're going to do is set up a system that works like the water cycle. So we are mimicking the water cycle on the Earth. And we need some ocean water. So here on the lab table is what we're going to use to create water that's similar to water that's in the oceans. We're going to use 100 milliliters of water and 3 grams of salt. And so I'm going to put those in this beaker. Oops, I spilled just a tiny bit there. That'll be okay. And the 3 grams of salt mixed with the 100 milliliters of water is called a 3% salt solution. And the reason why that's important to know is that the salt water in the ocean is also a 3% salt water solution. So
cool.
Yeah.
So you're basically making ocean water in that beaker.
Right. And those of you who maybe
Awesome.
have been fortunate enough to go to the ocean before, maybe you've already experienced that, where you know how salty that water is.
Yeah, 3% salt solution is really salty.
Really salty.
Yeah, you would not want to drink that.
And you can even see how cloudy it is now
Right.
in comparison to
Yeah, look at how that
regular
salt has
water.
dissolved. That's cool.
All right, so now that's dissolved. And what we're going to do is bring it over to this setup.
Don't forget the TDS reader, Mrs.
I'm
Monishin.
so sorry.
Yep, that's okay.
So we need to get a reading of how much salt is in here. Remember, salt is considered a pollutant in this case because it makes the water less than pure.
Nice.
All right, so I'm going to put the TDS reader in here. And we've got a reading of, let's say 580.
I'm going to zoom in as close as I can, you guys, to see.
570. No, it keeps jumping around. Let's go with 572.
Okay.
But if you look in the upper right-hand corner, right here, you'll see that it says times 10.
Yeah.
So we need to add a 0. So what we're talking about here is there are 5,720 parts per million. In other words, that's how much salt is in there. Remember when we measured the tap water and the distilled water earlier, our numbers were much lower than that. In fact, anything over 500 is considered highly contaminated. So this is a very large amount of pollution. All right.
Yuck. Yeah. And so students, what you're going to do is record this number just like I did on page 4. This is the dissolved mineral or salt concentration in ppms before we heated it. So our ocean salt water before heating. Record that number.
Okay.
All right.
All right. Now
what do we do with it? Mrs.
Okay, so
Monishin?
now we're going to take this salt water that we've created that's very salty, and we're going to pour it into this flask. Now
looks kinda cool.
This is going to be really cool. So this flask is sitting on top of a Bunsen burner, and the Bunsen burner will be like the sun, all right? And it's going to heat up just like the sun does in the middle of the day. It heats up the ocean water. And we're going to heat it up pretty intensely so that the water will begin to boil and evaporate. And after that water has evaporated, we're going to collect it after it has, so it'll go from liquid to gas, and then as it cools from gas back into liquid. And we're going to measure, using the TDS reader again, how that affects the salinity or the amount of salt that's there. And see how the water cycle works.
Nice.
So we're going to set this all up.
Okay.
And the way that we do that is take this stopper, put it in here so that the gas doesn't escape as it evaporates. And then we'll put the other end of this tube into this empty flask. And it's sitting in this cold water so that as the gas goes through the tube, all right, it will land in this other flask and cool down.
So that'll help it condense.
Right.
Yeah.
So we've got water here, liquid water that will boil, all right, evaporate, turn to gas. The gas will go through the tube, and then as it gets into this area, from gas back into liquid.
Cool.
And then this is the water that we'll eventually measure.
Awesome.
Okay, so let's get the Bunsen burner
Yeah,
going.
we got to get that Bunsen burner going.
Get some
This
heat.
will be fun to watch.
All right.
Okay, here we go, everyone. Ah, yes.
We'll get
Yeah,
that
make that
blue
flame nice and
flame
big.
nice and high.
Woo! We got a little draft in here, I
Yeah, a
think,
little
so
bit.
we're getting a little breeze.
Okay.
Nice.
Now this will take some time, and so we'll show you the video after the water starts boiling.
All right, we'll see you guys in a moment.
Okay.
Hi, everybody. We're here for just a quick check-in to see how the lab is progressing, okay? So just a reminder, we've got our boiling water here, our heat source representing the sun. So we have a lot of liquid water that's evaporating, turning into a gas. That's being trapped inside this tubing. And then as it moves away from the heat source and cools and condenses, it's starting to drip out this orange tubing into this small flask. And so as Mrs. Von Eschen zooms in, you can kind of see where that line in that triangular shaped flask, that's the liquid water that we're collecting at the end of the process. And you might also notice this steam coming out from this flask. So we're not quite able to capture all the water. Some of it is escaping still as that steam, that vapor, but that's okay for this lab.
Okay, everyone, we're going to be filling in the final data for this lab on the top of page 4. So follow along so that you can record these numbers.
Okay, everybody, so we disassembled our setup here, and we had to let things cool because everything was really, really hot. You can see some steam is still coming out of the original salt water that we were heating, okay? But it's cool enough that I can touch this. So I'm gonna just swirl it around and dump it into the beaker here, okay? Now, this is on your data table labeled salt water after heating. So this is our ocean water after it's been heated. And now I'm going to put the TDS reader in it. Oh, wow, Mrs. Von Eschen, see if you can zoom in on that. It says 7,000, let's go with 7,650 because the times 10 is flashing in that top right corner, everyone. Do you see that? So let's call it 7,650. The numbers were jumping around a little bit. So it was kind of a ballpark estimate there, but pretty close.
Okay, so this is our salt water after heating. Noticed what happened. Before heating it was at 5,720, and after heating it has gone up. Interesting.
Very interesting. Okay, we have one piece of data left, and that data is called the collected distilled water from our collection flask. So that is this flask that was where we were having that final recondensed water dripping into it. And before I measure that, I'm gonna rinse off, I have a little cup of distilled water here. I'm gonna rinse my TDS reader because there might be some salt stuck to it, and I don't want that to affect my results. And then that'll calibrate back down to 0. Okay, perfect. So now, this is our collected water. Let's see what happened. I'm going to tilt the beaker just a little bit so I have enough depth. Oh my gosh, Mrs. Von Eschen, can you get close on that?
Hi, ladies.
It was in the upper 30s. Whoops, sorry, it's jumping around a little bit here. I'm seeing like 37, 35.
35 seems to be where it's settling.
Yeah. Let's call it 35. That sounds good.
Okay, so that will be our last piece of data, the collected distilled water from the collection flask.
Yeah. And there was no times 10 flashing on that,
Yeah.
just to make sure. It was just the number 35. That is really low.
Very interesting.
Yeah. And you might remember something about that number, a number that low from our TDS scale. So below 50.
Ideal drinking water.
Interesting.
Hey, Mrs. Anderson, I'm
Yeah.
running a little low.
Oh.
Could you fill me up?
You bet. Gotta make sure you stay hydrated, everybody.
It's really important. Oh, thank you. That's going to help.
You bet. Cheers.